Well, hey everybody, hope you're doing well. You're going to need your science notebooks, and you're also going to need the bouncing ball lab graph that you did from Thursday. So go get those if you don't have them. Okay, now that you have your graphs and your notebooks, let's go over a couple of things. What you can see in front of you is the lab, or a graph similar to what we did the other day. Let's go over some of the parts of the lab, or the graph. I keep calling it a lab. At the very top, you have a title. Make sure that your graph also has a title. You have the y-axis labeled over here. Make sure that you have the units. In this case, it's centimeters, so the abbreviation is cm. You'll notice that I put this in as 0 down here, then 10, but I didn't write 10 down, 20, 30, 40. You can see I skipped every other line. I did the same thing across the bottom. The x-axis down here is the height of the drop. It also is in centimeters. Then I went ahead and put in my dots for the data that I graphed in class. So there's one right there, there's another one right here. You'll notice that some of those fit on the line, some of those fit above the line or below the line in equal amounts. I also drew the line of best fit. And when I did that, I extended it way beyond the graph because, as we talked about in class, these lines actually go to infinity and beyond. So now, what I would like you to do is to use the graph to make a prediction of how high a ball will bounce if I drop it from a height that I didn't actually measure. So for example, in class, I don't think that we dropped it from 80 centimeters. Even though I've got a dot there, let me show you how, well, let's do 100. How I would actually figure out how high it would drop from 100. So what I do is I come to the bottom on the x-axis and go to 100, then I go straight up until I hit the black line, and then I go over to the left and I read where that would be. So it's just a little bit above 60. So I would predict that somewhere around 62 centimeters is how high the ball would bounce if I dropped it from 100 centimeters. Let's see if I can do that again. So let's do, here's 140, 160, how about 180? So I'm going to go up the line right here until I get to that spot. Then I'm going to go over to the left until I get there. It's right in here someplace. Well, I know that this is 100. The next line would be 110, and it's a little over halfway between 110 and 120. So what do you guys think that would be? Yeah, I'd go with like 117, maybe 118. Those are probably pretty good predictions as to where the ball would bounce if I dropped it from 180 centimeters. Now, your graphs may not go all the way up to 180 centimeters, but what I'd like you to do is to choose 5 other points on your graph and predict how high the ball will bounce if you drop it from those heights. So for example, you might do 10. I'm just going to pick some here, pick some random ones. I'm going to do 10. I'm going to do 35. I've already done 40 in class, so let's do 50. I've already done 75 in class, so let's do 85. And let's do something over 100, so I'm going to do 120. All right? So I'd like you to look at your graphs, write these numbers down, the 10, the 35, the 50, the 85, and the 120, and then go ahead and predict how high the ball would bounce if you dropped it from each of those locations. Okay, now when you come to class next time, not next week because next week's Thanksgiving, but the week after that, we're going to take a look at the predictions that you made, and then we are going to move on to another activity. And the activity that we're going to move on to is this. I'm going to give you a simple problem. The simple problem is this. I am going to give you a single, that means one, Pringles potato chip. Your challenge is to build a container that will hold the Pringles potato chip that you can put into an envelope, a regular size, office size envelope, and we're going to mail it to Shali. And then the next week, in class, you guys are going to open those envelopes and see if your potato chip made it through the mail without getting crushed. Well, I'm going to bring some materials with you or to class for you. I'll bring some cardboard and some paper and some tape and maybe some plastic wrap and things like that. So I'll have lots of materials available for you. So you will build this little container in class on Thursday. You'll stick it in the envelope, we'll put a stamp on it and mail it, and then we'll see how well you do. So that's going to be your challenge when you guys are in class the next time. So that's it for me, except I do have a shout out to Seth and Isaac's dad, who is a doctor and actually did some work on me today. So thank you guys for letting your dad work on me. Everybody else, have a great few weeks, and I will see you in a couple weeks. Thanks. Bye.